Hello and welcome to Mechanics Solver, the TI84 calculator program that will help you with your physics questions, the mechanics ones specifically. Okay, so we've got A star physics. A star from, let's go say California, from Florida. I'm in California. She had physics, I guess, 10, 20, unit 2 practice problems. She said, hey, can your calculator do this? And I'm like, I think so. So let me go through it. Okay, so for those unfamiliar, this is the program available at mcsstudent.com, and we're going to go through this. A lot of these are centripetal motion, so we're going to go to 7, the more menu, and that's centripetal. Now, actually, let me do something first. Each sub-menu here, like centripetal force, mechanics, dynamics, yada, 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 they all have a help menu. So if you're completely unfamiliar with physics, which is okay, it'll walk you through. Like, so centripetal force is directed toward the center of a circular path, keeps object moving in circular motion. Example, car on a curve, ball and string, moon orbiting Earth. Boom, that helps set you up. And the A, and I'm trying to do a subscript here. That's AC, A, like with a little c subscript. That's centripetal acceleration. And then F with a little c is centripetal force. And there's the equation for it. Okay. And then we go on. We got T equals mv squared over r. Tension and string for circular motion. And we've got the units, yada, yada, yada. Okay. So without further ado, let's do this first question. Okay, I'm just going to start labeling things, by the way. Ball traveling in a circle. And if I sound too caffeinated, put decaf in the comments and I'll slow down for my next videos. Okay, I'll slow it down now. So this is a minute into the video or 2 minutes and I'm chilling out. Okay, ball traveling in a circle with a constant speed, also known as velocity. Physics people can flame me in the comments. Has centripetal acceleration, so A sub c. It's a funky little a, of 9.0834 meters per second squared. What's the radius? So the radius is the unknown. I usually circle the unknowns to kind of keep them separate. So we've got V, A sub c. We're looking for R. So let's look at this equation. And so if you're at a loss of what even formula to use, you can look here and like, okay, what has V, A, C, and R? We're like, oh, okay, cool, the first thing. Cool. So in this case, we're trying to solve for the radius. That's the beauty of the program. You can solve for usually any missing variable. So the velocity is that same speed there, 12.112. And then the acceleration, 9.0834. There we go. So that's going to be 16.15 meters. Oh, wait. And this is cool. It says replace the question mark. So this specific instructor wants that, like 3 digits here. Now, look, every specific teacher, instructor, professor, TA, whatever it is running your class has very specific rules about what they call significant figures or significant digits or sig figs. I'm not going to abide by those, but be sure to abide by them. Even if you don't understand the physics, you do want to learn the rules of sig figs. It's just to help you out there. Okay. Because you don't want to get the answer right and then get dinged for not using the correct number of significant figures. Okay, enough of me finger wagging. A car with a mass of 1,064.1 kg travels around a curve. Oh wait, what was that? Car in a curve? Car in a curve, centripetal, baby. So this is the mass. We're going to label that M. The radius, R. And then the speed, otherwise known as velocity. What's the magnitude of centripetal force? That's F sub c. That means subscript. I always wonder, they say sub c. What are they talking about? They're substituting something. It's a subscript. It's like a superscript would be up top, like if I did x squared. 2 is the superscript, not the subscript. Okay, boom. Okay, sorry, getting off topic here. So we're looking for FC, and it looks like, okay, cool. We got our second equation. That's beautiful. FC, and we want to solve for FC. So what is the mass? 1064.1. And I would recommend you are careful about entering the units. I'm known to not enter units correctly, so it's more a note to self. So the velocity here, the 27.597. There we go. And then the radius, 40.395. Okay. And then we get 20,062 newtons. Oop. I can't even spell a letter, man, and English is my first language. Shame on me. Okay, now on to the third question. Balls twirled the end of the string. That sounds like centripetal, going from that help menu there. So we're doing the ball and the string thing. So when it tells me kilograms, I'm like, oh, that's a mass. End of a string in a horizontal circle with a radius. Oh, that's R. Ball travels the constant speed. Oh, that's velocity. What's the tension? T is up for grabs. So it looks like we got this third equation, T equals mv squared over R. Okay, good. And then we're solving for T. And then we're going to substitute the mass. So that's 0.20244. There we go. And then velocity. So look, here, look, I'm telling you this. I'm the guy who was blindly entering units. I would have just now put 0.60372 because I'm a little sleep deprived. But I'm like, wait, V is over here. It's the 4.0957. So I just want you to be aware of that. So when I say things like that, like, oh, be sure you do this, be sure you do that, I'm not being condescending. I'm speaking to my younger student self. That like, dude, I entered units incorrectly. When I was your age, I got dinged so many times for entering the wrong figures in my calculator. Okay, and then so we got the tension is how many? It's three things he wants after the 6. So 6, 2, 4, 9, and then be sure to label units too. Again, that's something that dinged me. I'm more a math person than a science person. I don't know if there's such a thing, I guess, but I'm like, hey man, if I get the number right, am I right? Science people are like, no, you're not. Okay, we go on. Question 4. A planet with a mass. Oh, cool. Oh, there's 2 masses, so I'm going to call this M1, mass 1. This is mass 2. Distance, also known as a radius. Okay, so radius could be a distance between things, because what they're talking about is like, there's this big old planet, and there's gravity, and then there's this big old planet that's like M1, M2. And this distance between them is also known as a radius. I know. Radius, I think circles. Me too, but, whatever. That's how it is, I guess. So in this case, we're going to go to, we're skipping around here, gravitational. So the gravitational force, well, I'm going to assume that's F equals G M1 M2 over R squared. Now, if we're not familiar, G is, what do I want to say? It's a constant. It's the universal gravitational constant. Do I have an help menu? Oh, I do. Ha ha ha. Okay, good. Examples: Earth, Moon, Sun, Planet, or 2 planets, I hope. And then gravitational field strength. Earth G is 9.81. Oh, unless you're in like AP mollycoddled physics. Oh, we're gonna round it to 10, dude. Intero bang me, baby. Okay. Gosh, I'm getting. Man, I'm like probably undiagnosed ADD. They didn't do that in the South back in the 70s and 80s. So I am undiagnosed, baby. Let's solve for the F here. M1, 6.0087. Okay, and then one thing I want to talk about here, excuse me, that's times 10 to the what? Well, when you raise something to a power, use this symbol here. It looks like an up arrow. It's called a caret symbol. I'm not even kidding. You can look it up. Raise the 24th. Because a lot of students are like, what? How do I raise something to a power? And this is how you do it. Unless it's squared, you just put the x squared thing here. Mass 2, 2.0068 times 10. And again, raised to the 30th. The radius, 50544. I'm pretty sure there's 7 zeros here. I'll just try my luck. 1, 2, 3, 4, 5, 6, 7. Okay. And then we get 3.150. And I'm going to round this up to 2 here because the digit after it, if it's 5 or larger, we round it up 1. So that is a 5. So that 1 now becomes a 2. Okay. And then E to the 21. Let me explain that too. For them familiar, that's 10 to the 21st. Okay. So anytime you see E21, that would be times 10 to the 21st. If you have E to the negative 21, that would be times 10 to the negative 21st, which means it's a tiny number, not necessarily a negative number. The negative would have gone out front. I do know some things from math. Thank goodness. Okay, not so good with the physics. But here we go on problem 5, almost halfway through this puppy. Okay. So a rope applies a horizontal force of 18 181.64 newtons. So that's force 1. A distance, so that's D, a frictional force of 121.61 newtons opposed to this motion. So this is F2. And just so you know, usually, let's see, if this is positive, right, this 181.64, this guy is going to be negative, or gal, or whatever is going to be negative. We want the work done, so we want like work. Okay. Now, this is what is confusing, okay? Everything's confusing but in physics, but this is more confusing about my program. This is work energy here, so I apologize. Flame me in the comments, or subscribe, or like, or dislike. I have it in another option, like other work. Because I have a total work thing here, I didn't want to confuse it with the work energy. I don't think I had space in the submenu. But because I didn't run into a problem like this until the student submitted the PDF. But let's go to the total work. And it's net forces, because there's multiple forces acting on it. So we're trying to find out what is the net force. So number of forces is 2. And again, force 1, oh, look at my lame formatting. 181.64. I'll probably clean this up in the next iteration of PhysSolve. Force 2 is, okay, now we're going to put that negative, and that's the negative key below the 3 to the right of the decimal, to the left of enter. That's the negative key. It's important to use that rather than the minus. I know, in your brain they're the same thing, but in the calculator, not. Okay, wait, oops, look at me. I'm putting in the wrong digits. Remember that joke earlier about me not entering things correctly? There I go. The distance is 2.0458. There we go. And then so we get 122.8. And I'm going to round it to 8.1. Because again, after the 0 is a 9. That is 5 or larger, so we're going to round up. And that's going to be J for joules, baby. Okay. Oh my gosh, we're almost halfway through. Now this next one, low pointed swing, pendulum bob. Ooh, pendulum. So I think immediately we're going to go to more. And then I got pendulum here as an option. Okay, the mass here is 0.2. Oops, I didn't lock this figure or this image. Has a velocity of 5.0509. That's going to be V. How high will the bob swing above the low point? So it looks like we've got a situation here. We're doing PE equals mgh. If you needed help, we got the help here. H is max height, reach, and swing. Beautiful. That's what we want. Potential energy at height H. And then we go on. Yada, yada, yada. You can press pause. Okay. So I think it's just going to be the, or is it the V squared over 2 times G? I don't know. I don't. Is it going to be 2? What am I going to do? We are going to do the H equals V squared over 2G. So we're trying to solve for the H. Oh, how high? I didn't even circle that. Forgive me. We're not doing this one, by the way. Man, forgive me. We're going to solve for H. And then what's the velocity? It's 5.0509. And then the G, again, that's the acceleration due to gravity, 9.81. And the height looks like it's going to be 1.3003. Again, because what's trailing the 2, that's called trailing the 2, is the 8. And that's larger than 5. So we're going to, or 5 or larger, so I'm going to round that up to 3. And that's going to be meters. Okay. Oh my gosh. So it's H equals V squared over T. And again, has everything we wanted. Okay, great. Question 7, let me lock it up. So question 7 is a little different. It's a ride on a sled, combined mass. Okay, so this is our mass on top of a hill, which is 15.949 meters above ground. The sled is given a push, providing, okay, this is KE, kinetic energy initial, is the 1606.2. What's kinetic energy final? So that's KE final. So if they ever say KEF or KEI, kinetic energy initial, kinetic energy final. Okay, reach the bottom of the hill. So what we're going to do here is we've got to calculate, and let me write out, this is not in the program. So man, this is like big thing. So KEF is KEI plus PE. And let me explain that. Your kinetic energy final is equal to the kinetic energy initial plus potential energy. So a little more in depth, KEF equals KEI plus, and I'm pretty sure potential energy is MGH. So really the only thing we are missing is this MGH guy. Because we've got our M, our G, G is 9.81. So we're just going to calculate this. This is the potential energy. So when we go here, what we want to do is calculate the PE, the potential energy. So we're going to go to the work energy, okay, and we're going to go to PE, the MGH equation here. So we're going to solve for that potential energy. And then the M, the mass, is 50.827. And then the G, that's the 9.81. And if you didn't know, I do have it in units, and I have it in a lot of places if you forget what it is. But in AP Physics, you guys have it as 10. I have no idea why. It just is. Okay. The height, 15.949. Okay. So potential energy is 7952.37664. Okay. And then also, we already had that kinetic energy initial. They already gave us a number, thank goodness. That's 1606.2. So I'm going to take the liberty of using a different calculator. Again, it is actually TI84. I'm not kidding. I have more. Sometimes I feel I have more calculators than stables. Okay. So this comes out to be 9558.57664. So it looks like the instructor wanted one digit after, or one digit to the right of the decimal. So that's kind of going to be this. But again, because the 7 is greater than 5, we're going to do 9 or 5 greater. 958.6 joules is our answer. Love it. Love it. Okay. We're going to continue. Question 8 here. Yeah, let's stick with the green. We're doing well so far. Suppose a spring with a spring constant. Okay, so a spring constant is a K, and probably some German guy figured out constants with a K, because in America and England and English-speaking countries, you're like, why is constant K? Probably German beat everyone to it. Compressed by this. Again, this is X. So let me explain to this. We're going to go to the More menu, and then this is springs. And then let me go to the Help menu to explain this. So we get F equals Kx, Hooke's law. K is a spring constant. It's the stiffness of the spring. So I guess the larger the K, the stiffer it is. So Slink would have like 0.001 or something. X is displacement from equilibrium. That's this thing. It's compressed. And it's a distance. It's not an unknown thing. Well, I don't want to get into it, but it's a certain value here. So what we're going to do is, projectile, and this is an M. So we want the speed, the V is the unknown. So what we're going to do is figure out, okay, wait, which equation we're going to use. So which equation has most of these things in it? Looks like the only thing with a V in it is option 3. So, and then we're going to solve for V here. And the K, the spring constant, 60, oops, look at me making a mistake again, 604.78. And then X is 0.40629. And then the mass is look at this, 50434. Look at me. 44.491. How many digits this guy wants? 3 after decimal. Okay. And then label units, meter per second. Okay. Labeling units, I recommend you do that, but I am a big hypocrite because I don't label my units a lot. So, you're forgiven, I'm forgiven if we forget to do that, but you'll probably get dinged point-wise. Okay. This thing, we got 60, we got kilograms, so I'm assuming that's mass. We're doing a speed, which is velocity for most people. It's brought to rest in a time of, okay, rest. Okay, so this is velocity initial and then velocity final. Okay, so rest is great. You know, like everybody needs a day of rest, right? But rest in physics means your velocity is 0. Okay, so velocity final 0. And then your time, your t, or your change in time is 0.400. What's meant to, excuse me, the average force exerted on the object during this time. We got an F there. So what we got to do is go to the More menu here. And then I think this is impulse, because I think that deals with forces like this. And we're pushing it, so that's F equals ma. So we want to solve for the F. Now, like let me explain something too. Skip if you already know what the delta means in math, science, and economics and everything. But this triangle symbol, it's also called a delta. Okay, and it means change. So when they say delta t right here, delta t, that means change in t, change in time. Delta v, change in velocity. So that's what it means. I'm just trying to dispel a lot of the jargon of physics and whatnot. So we go on. And then we are trying to solve for F. And then, okay, what is the mass? The mass is the 60.43. Great. And then velocity initial, CV initial, 80.759. Velocity final, okay, it's brought to rest, so that's 0. And then the delta t, the time change. Oh, we just had a time change. It's too funky, at least in my state. I don't know. They've outlawed it, but they still haven't put it into effect. I don't know. I guess we're all outlaws or scofflaws right now. Okay, so the F is going to be, now when they say negative, by the way, they mean in the opposite direction, because this object is moving this way, and then let's call friction a yellow force here. It's going that way. So, oh, yellow and blue make green. So there we go. So the force is 12. And I'm just going to, like, if this guy has a positive, I'm just going to err on the side of caution and agree with that professor and say it's 12,197 newtons. Okay, we go on. We got a railroad. Railroad cars running into each other, man. This is no joke. This could be really bad. So railroad car, I mean, like bad in real life, not in physics world where, you know, no one ever gets hurt in collisions. Railroad car, so this is M1, and this is going to be V1, or V1 initial, is a 12.136 meters per second. Collides the second car, mass initially at rest. Oh, what the? I don't have the mass here? Oh my gosh, hold on. I didn't even copy it down. It's 18,532 kgs. Oh my goodness, forgive me. So that's M2. And at rest, right? We already learned what that means. So V2, or V2 initial, is 0. What's the final speed? So we went velocity final. So let's go to collision. Now when things hit each other, they're called collisions. So it's going to be 5. And then I'm going to go to help menu just to explain some things. If you already know this, you can skip ahead a minute on the video. Conservation of momentum, blah, blah, blah. And if you're, you know, I'm at a loss, I'm like, oh, I forgot what inelastic means in physics. I know what it means in economics, but in this, momentum's conserved, but kinetic energy not conserved. Objects might stick together or become deformed. This is your big help. Now, deform means like they hit each other and then one crinkles, kind of like a body panel of a car. When it hits something, it becomes deformed. And then car crashes, clay balls, those are examples of inelastic. So perfectly inelastic, there's our formula. And then elastic, blah, 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 blah. So what we're going to do is go to inelastic. So there we go. And then our mass 1 is going to be the 12,073, right, kilograms. I hope everything's kilograms. V1 is the 12.136. And then our mass 2, which I didn't copy, my bad, 18,532. That's a massive thing. V2 is initially at rest, so it's 0. Okay. So velocity final is 4.78738. And it looks like our guy wants, let's see, that's 3 numbers after 7, so it's 1, 2, 3. Okay, so it's going to be 4.7874, right? And I think it's going to be meters per second. Okay, so there we go. Cool with that. Oh my gosh, on to the last question of the day. Good, good. I'm getting a little tired here. You probably are too. So what we're going to do is another collision thing. So we got to go to more. We got to go to collisions. Now, let's just assume west is positive and east is negative. So I'm just putting that, and you might want to put that in your notes when you're doing a problem like this, because if they're moving in opposite directions, one's going to be a positive velocity, the other's going to be negative velocity. So what we have, they stick together, so I'm assuming it's inelastic. So mass of 1, that's the 1542 point. I'm getting sloppy here. Let me just label that. That's our mass 1. That's our V1. This is mass 2, and this is our V2. Just the V2 is going to be negative because it's traveling east. For me, it's going to be negative. 2 vehicles stick together after collision with the speed of the vehicles after. So the V1, again, is 25.566, or 5, yeah, 66, okay, good. And then M2, 4515.7. And then our V2, I'm going to write negative. So remember, the opposite direction is going to use this negative key, 15.472. Okay. And then we get negative, but I didn't write negative, so I'm just going to keep it positive. 0.02. How many places? 1, 2, 3 after the 0. So I'm just going to go 5.0211 meters per second. Okay, great. There we go. If you have things that you'd like to see added to this program, definitely comment. I do read all the comments. And then if you want to message me at mcstutoring.com, the website, the link's obviously in the description and probably the pinned comment. So, and this is how these things are born. Like, students say, hey, I bought your program. It doesn't answer everything on my PDF. Let me send you the PDF. I'm like, okay, cool. And then I revise the program and it does everything and everybody's happy. And there we go. Oh, and you get free updates for life. So don't worry, if I revise it, you won't be left out in the lurch or left in the lurch. Okay. So good luck and everything. I'll catch you next time. Bye-bye.